Alright guys, here's a little bit of a slower explanation of what we were talking about on Friday. So the first thing I want to stress again is what exactly a radian is, because it's what we're going to see a lot of in the future chapters. So what it means to be 1 radian, if an angle were to equal 1 radian, that means the measure of that angle is equal to the intercepted arc, which is also equal to the length of the radius. So in the example here, if I drew in the radius, that would be r. An arc that is 1 radian would be as if I took that black line and I flattened it on the outside here so that this arc is the same length as it. So the length of that arc would be equal to the radius. And then the angle that's formed here is said to have a measure of 1 radian. So if we call this theta, theta would measure 1 radian. So 1 radian happens when the ratio of the length of the arc to the radius is they're the same number. So 2 over 2, 3 over 3, 4 over 4, but it's going to reduce to 1. The ratio is just 1. There are other radian measurements, though it doesn't always have to be 1. So that's what this equation is talking about here. If you want to find the radian measure of any angle, you can do the ratio of the arc length, is what S stands for, over the radius. Anytime you do the length of the arc over the radius, it's going to tell you how many radians it is. So that should make sense because we know that it's 1 when they're equal. So anytime the arc length is less, it's going to be less than 1. Anytime the arc length is longer than the radian, it's going to be greater than 1. And I have a visual on the next page I want to show you. So the problem we skipped here, it says central angle has a radius of 12 feet and intercepts an arc of 42 feet. What's the radian measure? So you just need to understand that radians is whatever the length of the arc is that goes on top divided by the radius. That's the ratio that a radian measures. So we would divide those and we would get 3.5, and it would be 3.5 radians. Let's try the next one. So in this demo here, the scale along the bottom, this part down here, is going to show you what the radian measure is as I move the angle around. So if you watch, I'm going to show you what it looks like when we get to 1. So there's about 1. Right there. That blue line would be the same length as the radius, which is here. It's just the same length as the radius. But if you notice, that's not the only radian measure. If I go past that point, it can get bigger. If I go shorter than that point, it can be smaller than 1. So it's just the ratio of whatever that blue arc is to the length of the radius. As the arc gets longer, the radian measure gets longer. What I also want to look at here is what happens when I go halfway. If I go halfway across the circle, you should notice that that measurement is something familiar here. I can get it to stay. Half of the circle is going to be pi, and then all the way around the circle is 6.28, which is really 2 pi. So I hope this just gives you a better idea of what a radian measure is. So let's go back to the other page and use that. So on this page, I was trying to explain in class why we're going to get the formulas we're going to get. So hopefully now you understand that a radian measure is really just the ratio of the arc length over the radius. So in a generic circle, if I were to go 1 rotation all the way around here, that is going to be an arc length of 2 pi r, and the radius we're just going to call r because that's a whole circumference, so twinkle twinkle little star, circumference equals 2 pi r. So then what happens here is these cancel. So 1 rotation in radians is 2 pi. We also know what one rotation is in degrees. It's 360. So a ratio I really want you to understand is if we take that ratio and we just reduce it a little bit, is that the ratio from radians to degrees is that 1 pi in radians is equal to 180 degrees in degrees. So that's what these two things talk about here. These are formulas that you could memorize. But I kind of have an easier way to talk about this, and this is what we didn't get to finish in class, is that if you want to convert, if you just remember your conversion is pi to 180, as I think of these in terms of how you guys did them in like chemistry, is setting up a table here. If I want to convert the degrees out, all I need to think about is the one that goes in the bottom has to be the one that matches, so they cancel. So 180 degrees would go on the bottom, and pi would go on the top. And what happens here is the degrees cancels out, which is what we're trying to do. We're trying to convert, so we want to cancel out that degree measurement. So then we would get 60 pi over 180, and then you would just reduce that fraction. You can divide those both by 60. This is your radian measure, pi over 3. Let's try the next one. So again, 270 degrees converted to degrees means I have to put degrees on the bottom so they'll cancel. Pi goes on top. Cancel those out. We get 270 pi over 180. These cancel. It's going to take me a little bit longer to reduce. I can cross up the zeros and then I can reduce those by 9. So it's going to be 3 pi over 2 in radians. So anything with a pi is considered a radian answer. Anything with a degrees is a degree answer. They're two different measurements. And then this last one, it's negative. Again, it's degrees, so I know my 180 degrees is going to go on the bottom. Pi is going to go on the top. The degrees are going to cancel out. And then my goal now is to reduce negative 135 pi over 180. Let's see, I can divide those both by 5. So that's going to be 36 here, and if I divide that one by 5, it's 27. And then I can divide them by 9, so I get negative 3 pi over 4. And you guys, of course, could use your calculators to reduce it. Alright, the next ones we're just going to go the other way. So for these next problems, we're trying to convert from radians to degrees. So again, I think of this as a conversion problem, so I'm going to do my little chart here. When it's a fraction, the pi goes on the top, the 4 goes on the bottom. And then I have to fill my conversion in on the other side. The conversion, what you have to remember, it's the only thing you have to remember, is that pi equals 180 degrees. Those two things are equal. For this one, to get the pi in this top left corner to cancel, I'm going to have to put the pi down here in the bottom right corner. So pi is going to go here, 180 degrees is going to go there. The pi's are going to cancel each other out. So we just get 180 divided by 4, which you can divide on your calculator, and it gives you 45 degrees. Let's look at another one. The next one's negative. So again, set it up as a fraction, put the top part in the top box, the bottom part in the bottom box. So it's negative 4 pi over 3. In order to get it to cancel, the pi is going to go in the bottom, 180 degrees goes on the top. The pi's cancel out, and then we just combine what's left. So that turns into negative 720 degrees over 3. And then if we divide that, that's negative 240 degrees. The last one's a little bit weirder, mostly because it doesn't have a pi in it. So I would make sure to label this as 6 radians. And then you have to decide where the 180 is going to go and where the pi is going to go. So of those two, 180 is degrees. Pi is a radian measurement, so pi is going to need to go here. Pi is the radian measurement. 180 degrees would go on top. So the part that cancels out this time is the radians that cancel out the fact that they're both radian measurements. and then we just have to multiply across. We get 1080 on the top over pi on the bottom, and then you just have to divide that on your calculator. The pi doesn't cancel this time, so it's not going to come out to a whole number. So it's going to be 343.8 degrees. That's the measurement in degrees. And make sure you keep the degrees there. I think I keep forgetting that, but bring that with when you multiply the top out. And then the last part is just taking that formula that we had on the other page. The formula said that the angle measure is the arc length over the radius. They've just solved this for arc length instead. So if they give you a problem and you want to find arc length, we can do that now. This one says express the arc length in terms of pi and as a decimal rounded to 2 places. So we're going to have 2 parts to the answer. The fact that it says that it needs to be in terms of pi means that we have to convert this degree measurement here. So I'm going to do that first. So that's what we were just doing above, or actually on the other page. I'm going to take the degrees and I'm going to convert it to radians. So since the degrees is on top, the 180 degrees is going to go on the bottom, so they cancel. The pi goes on top. The degrees cancel. We get 45 pi over 180. Reduce that. It's really pi over 4. And then we can use the formula. The formula says that the arc length, which is what we're trying to find, is the radius times theta. The radius is 6. Theta is what we just found is pi over 4. And we just multiply those. That's 6 pi over 4. Reduce it, 3 pi over 2. That's your answer in terms of pi, and then to get the decimal answer you can just use your calculator. If you type it in your calculator, the decimal answer is 4.71. So we would do a similar thing in number 2 here, is we would take the degree measure and first convert it into radians. So again, the 180 goes on the bottom, the pi goes on top, so they cancel properly. Degrees are across from each other, so they can cancel out. It's 240 pi over 180. And then we have to reduce that. Those, you can divide both of those by 60. So it's 4 pi over 3. And then to find s, it's going to be the radius, which was 10 feet, times 4 pi over 3, which is 40 pi over 3. And then you just have to type that in your calculator to get the decimal answer, just because they want both. So in the calculator it turns into 41.89. So hopefully this helps you, and you can complete the homework. Have a good rest of your weekend.